recording? Okay, so we're now recording, and we're going to talk about the confidence interval practice test. Here's the first multiple choice question. A Gallup poll interviews 1,600 people. Of these, 18% say that they jog on a regular basis. News report adds the poll had a margin of error of plus or minus 3 percentage points at a 95% confidence interval. So what can we conclude from that? So in this case, if you look at A, 95% of all Gallup poll samples like this one gives answers within plus or minus 3% of the true population value. The percent of population jog is certain to be, definitely it's not B. That's not really quite where we're saying the confidence interval. 9% of the population, it's not a probability, so C is out. We can be 95% confident the sample proportion is captured. That does look pretty good because that's kind of what we're trying to say there. If Gallup took many samples, 95% of them would find that 18% of the population in the sample jog. That's kind of tricky, actually, because E does make sense. I mean, that's kind of what I've been saying. If you do this 100 times, 95% would contain the sample proportion, but and the sample proportion is 18%. 9% all Gallup. Yeah, we can't say that because this is a little too definitive because it has the word give answers within. Yeah. So I wouldn't say A. Yeah, I think D is probably a safer choice because we assume the sample proportion. Also, we didn't do this randomly either. That's kind of a problem that we should have said that. But that one's kind of a strange one. I'm not going to be asking a question quite like that, but I probably would say D. The next one, definitely we can do. The weight in pounds of 3 adult males is 162, 15, and 195 was the standard error of the mean for these data. Okay, so the standard error is going to be this part sigma over root n. So this right here, just so you know, is what we call the margin of error, MOE for short. But standard error is just this part here. So you do need to calculate what sigma is. Oh, am I not sharing my screen? Hold on a sec. Oh yeah, never mind. I thought I was not sharing. Okay. And hold on 1 second. Let me make sure. There we go. Try again. Okay. All right. So that way I can see if there's any chats or anyone has any questions. So what I was just doing again, the standard error is going to be this sigma over root n. So that's the form we have talked about. And I'll actually provide a formula sheet too. I'll put it in the week 3/4 folder so you guys have access to that. You need to calculate what sigma is. So that's where you can actually use your calculator, or you can use a Google form. Google form might be a little easier perhaps. If you're comfortable with that. So if I just do Google Sheets. Let me switch my school account. Blank. And my data was what? 160, 215, 195. So 160, 215, and 195. All right. So if we want the standard deviation, you just hit equals STDEV. And it's the whole thing. So you do for the entire population. So it's 22.73, but then you got to divide by root 3. So you can see that 22.73 is kind of there. Then there's a trap. So then you got to do 22.73 divided by root 3, because that's, you know, our sample size. And so you get about 13.13. So that's why the answer is E. So that's that one. Okay, let's keep moving. In preparing to construct a one sample T interval, we haven't done T intervals, so let's actually ignore that one. So yeah, we could have done it, but I just think, you know, we just don't have the time. And that's where you have to do something called degrees of freedom. But again, I'm not going to get into that with you guys. Let's look at this next one here. Many television viewers express doubts about the validity of certain commercials, attempt to answer their critics. Timex Group USA, which is estimated the true proportion of all consumers who believe what is shown in Timex television commercials. What is the smallest number of consumers that Timex considered a guaranteed margin of 0.05 or less at a 99% confidence interval? Okay. So what you want to do for this one, remember your margin of error is defined as Z times sigma over root n. Now, if you don't have sigma, in place of sigma, you replace it with root p times 1 minus p, just so you know. Or p hat, same thing, you know, but I don't really care whether you want p or p hat. Now, because we're not given the proportion, I guess we're going to assume 50% for P. I think that's usually what we do. Because I guess you want to see if there's a majority who's going to believe what they see on the television. So we're going to replace this. We're going to do Z times root P times 1 minus P over n. And we want our margin of error to be 0.05. We want it to be less than. So you're going to want that. For 99% confidence interval, well, Z always represents a confidence interval. It's a Z score. So you have to look it up, actually. So you do a quick search here. 99% confidence interval Z score. I think it's 2.576. Yeah, 2.576 right there. So that's just a Z score that you have to look up. And remember, you know, we're assuming a normal distribution. And so 99% means that you want the middle 99% of the normal distribution, meaning that each of these tails here are 0.05% or 0.5%. So 0.005 will be the proportion there. So you want 0.99 in the middle. So you'd have to calculate what that Z-score is. And there's ways you could do it in the calculator, or you can just look it up. Just do a quick Google search. Times root, and you're going to put 0.5 times 1 minus 0.5. So if you're not given the proportion, you just assume that. And you solve for n, and that's 0.05 right here. Now you have to do some algebra. So we divide both sides by 2.576, so 0.05 divided by 2.576, less than or equal to, and that's root 0.25 up here. That'll be root n. I'll just separate the radicals. You can cross multiply. So you have 0.05. Actually, let's just get that nasty decimal out of the way. So left side will be 0.0194. Up top is 0.5 over root n. If you cross multiply both sides by root n, and divide both sides by 0.0194, you get 25.76. And then you got to square both sides. You get about 6. That's interesting. I don't get the answers they have there. I wonder what I'm doing wrong. Only things that maybe I'm wrong assuming the p-value, but I should have got 663.58. So it should be 664, which I don't see here. See, that should be the answer. It should be 664 if your proportion is 0.5. Yeah, I'm not 100% sure what may have went wrong, but that's the calculator is supposed to do, and I'll make sure it works out fine on the test. We'll keep moving to number 5. So 9% confidence interval, unknown population standard deviation, sample size 30. So again, so you just do 9% confidence, you just look it up. I mean, that's just all I really do. And it's 1.645, there you go. So just say, just that simple. We'll keep moving. A radio talk show host with a large audience is interested in the proportion of P of adults in his listening area who think the drinking age should be lowered to 18. Okay. To find this out, he poses the following question to his listeners. Do you think drinking age should be reduced to 18 in light of the fact that 18-year-olds are eligible for military service? Okay. He asks us to go to his website and vote yes if they agree, and the drinking age should be lowered, and no if not. Of 100 people who voted, 70 answered yes. You probably would expect that. Which one conditions are violated? So, well, what I mean by 10% is that you want, remember independence? Let me actually go to our answer key for homework number 3 or worksheet 3. So remember, you want your sample size to be less than 1/10. That's meant by that. I'm pretty sure if we survey 100 people, that is less than 1/10 of all teenagers in this country. So I think that's fine. And then we don't know, the portion is 0.7 of our sample. So 100 times 0.7 is 70. That is definitely bigger than 10. The people said no, it's 30%. 100 times 0.3 is 30. That's still bigger than 10. So the 10% rule is fine. We didn't violate that. So 10% means for the independence and the normality. That's fine. Again, for independence, you want your sample size, which is hundreds, to be less than or equal to 1/10 of your population. I'm pretty sure there are like millions of teenagers in this country. So that's definitely going to be, or, you know, there's going to be lots of people listen to the show. So I'm pretty sure that's not violated. And for normality, you definitely need your sample size times the proportion who said yes, which is 0.7, to be greater than or equal to 10, which it is. And likewise, for the opposite situation, which it is. So we're fine there. So large counts, I mean, that's really, so the 10% was really more for, I guess, the independence part. The large counts, we want to make sure we have enough people that we're sampling, which we do. Because if you have a too small of a count, then you can't do normal behavior. So the large counts really means normality, just so you know. And I'll probably just say that. Does it satisfy normality? 10% is independence, I'll just say that. So it satisfies both of those. It's not random though, because the things that it's only people who are going to the site. And so it might be people who, so it's biased. It might be people who really want to have the legal age lowered to 18. So it really should have been more like, let's go, I don't know, go to different high schools and then have 10,000 teenagers, and then do a random number generator, assign them a number, and then ask those people. So it should have been done more randomly. But I'd say 1 was definitely violated. So I'd say A for that one. Okay, for number 7, a 90% confidence interval for the mean population. So remember, mu stands for the population mean. Is computed from a random sample and is found to be 90 plus or minus 30. Okay. Which one could be the 95% confidence interval based on the same data? Now remember, when you make this bigger, right? Higher CI level means you want to be more confident. So you need to expand the interval. So it's going to be more encompassing because you're increasing your confidence. So I think C could Well, definitely not A or B. And based on the same data, so you have the same population size. Just wondering, I just think 70 would be too much of an increase, is my guess. So I probably would say C, um, mainly because if you look at the different CI levels for 95 and 90, so it's 1.96 and 1.645. So it goes up. In fact, if you actually were to compute that, the ratio between 1.96 and 1.645, which is about 1.19. So it should be about a 19% increase, which seems kind of reasonable. I mean, go from 30 to 39, it's actually a 30% increase, but I think that would seem a little more reasonable than 7. I think that'd be too much of a jump to go from C to D, so I would go C on that one. But definitely has to get bigger. For number 8, suppose we want a 9% confidence interval for the average amount spent on books by freshmen in their first year at a major university. They also have a margin of error of at least, at most $2. Okay. Based on last year's book sales estimate, the standard deviation amount is 30. The observation is required. So again, we kind of saw this already. The 1.645 is a z-score for 9%. You can just do a quick Google search for that. The 1.645, and you're given the standard deviation, so you're going to do sigma over root n, and you want your margin error to be at most $2. So 2 is going to be bigger or equal to that value. And sigma again is 30, so I can replace the sigma here with 30. And you're solving for n. So you see the algebra at this point. So I can probably multiply both sides by root n and do 1.645 times 30, which is 49.35, divide by 2, which is 24.675, and then square both sides. So n is going to be 608.86, and so it's going to be about 609, because you got to be a little higher than that, right? So that's D. Okay, for number 9, a telephone pole that SRS, remember that's simple random sample, that's what that stands for, SRS. And it's called simple because what you're doing is, you're just, like, you say you have you're serving all people in Redwood City, how are they going to, vote for a certain election or proposition. You would assign each person of voting age in Redwood City a random number, and then you would use a random number generator and say, okay, number 25, who is number 25? Okay, you survey that person. Okay, the number 175, who is 175? You survey that person. So it's just done in a simple way, simple random sample is what SRS is. So it's good that we're randomizing it. That's always a good thing. And you have that many people in your survey, so 1,234 adults. 60% are generally satisfied with their lives, okay? The announced margin is 3%. Does margin account for the fact that some adults do not have telephones? So remember we talked about it's only really for the sampling that we, so if you look back at our presentation again, yeah, it covers only random sampling errors. No other source of error should bias the influence sample distribution. So the margin does not take these difficulties into account, like non-response or under coverage. So to answer this question, no, it does not. Yeah, only counts for sampling variability. That's why it's E. Any variation we see in the sampling, that's the only thing that's being covered by the error. It does not account for non-response. So remember, the presentation even tells us that too. Does not margin error does not take such as account, such as undercoverage or non-response. So that's why it's just E. Because obviously it's a lack of response. We have a telephone. And then number 10, then we'll go into a breakout room so you guys can discuss the free response. Again, if you did it, great. If not, then talk about it, work it out, and then we'll come back and go through that. So number 10, the Census Bureau reports on the income of Americans says that with 90% confidence, the median income of all U.S. adult households is that much. Okay, with the margin of 742, which defines the most appropriate conclusion. Okay. You can't say of all households. Again, it's not a probability, so it's definitely not A. We can be sure the median income of households kind of lies in the interval. Well, how sure? You got to be a little more specific than that. 9% of the household in the sample interviewed had incomes. And again, it's not a probability, so it's not C. The Census got the result using a method that will capture the true median income 9% of the time. Yeah, that probably could work. 9% of all sample size would result. Yeah, I like D a lot. I think D kind of makes the most sense for that one. If looking at E one more time, of all possible samples, yeah, I think that just sounds a little weird to me, the way that one is designed. I'll be kind of mindful of, I won't put both those choices because I think that does seem a bit ambiguous to me, but that is what we're trying to say. If you do this repeatedly, that 9% of all your samples would capture the true median, because we don't know what the true median is. And that's, again, that's just we got from one sample. Actually, now I know why E doesn't work, because because what we got $57,005, that's actually just from one sample. We don't know if that's going to capture the true median or not, and we don't know what the other samples are going to look like either. So that's not the population. Yeah, now I know why E doesn't work, because that's not the actual population mean. That's just a sample mean. But you want to actually capture the true median income. That's why it's D. So I think now I probably can answer that one there, where I was a little confused, I think, between yeah, I think E would make the most sense. Yeah, it's not the sample portion, so D is out. Yeah, now I know why D doesn't work. We can 9% of the sample portion is captured. No, that the true population proportion is captured. That's how we have to say there. Yeah, D definitely does not work for one now. It's definitely E. If you repeat it many times, 95% would be captured. Actually, no, it's not E either. It's going to be A. Okay, sorry for the confusion again. It's going to be A because this is still given the sample. It's supposed to be 9% of them would find that the true, we would capture the true value of people that jog in this country, or whatever your population is. Again, it's not the sample portion that you want to be captured, it's the true population portion you want to be captured. And because we have a plus or minus margin of error 3 percentage points, because that is indicative of our confidence level, right? Because confidence level impacts the z-score, the z-score impacts the margin of error of the true population value. So yes, that's what we had to say for number one. Now I know what I'd say. That one's A for sure. And for 10, it's going to be D, the true value. That's what we want. Okay, so anyway, I'll give you guys about 20 minutes or so to kind of talk about the free response. And then I'll kind of hop in each group and just make sure the surveys are fine, and I'll have you guys email it out and CC me. So definitely email as soon as I leave your breakout room. So that way I know that you sent it, and that we're going to start collecting data soon. And then at 1 o'clock, so we'll do a 20-minute break. So at 1 o'clock, we'll take a 10-minute break. We'll come back, we'll go over the answers here for the free response. And then hopefully if it doesn't take too long, we could end class a little early today. And then you could start the test right when class ends. Or you can wait till later, it's up to you, or do it on Saturday or Sunday. So let's put you guys in breakout rooms right now. And let me also stop this recording.